Okay, let's start. Hi, welcome to the second iteration, the second installment of Learn Web3 with Colony. Today we want to look into ethers.js, which is, let's say, a Web3 library. We used to call it like that when we just had Web3.js, and now it kind of stuck. So it's a Web3 abstraction library for JavaScript, written in TypeScript, and it basically helps you to manage all of the things. If you watched the last stream, then you've seen how tedious it is to interact with Ethereum nodes or smart contracts in general. And things like, or libraries like ethers.js make it a lot easier to do that. But we're kind of getting ahead of ourselves. I just wanted to some very quick housekeeping. Please note that we have a GitHub repository that is join colony /learn web3. I paste the link in the chat. That helps. And I usually keep it updated with everything that is concerning this course, and it will later also hold our main application that we're building. So for now, I'm just messing with the docs directory here. That's what I put everything in, like the agenda and all of the notes that were taken throughout the course, with all the lessons. And some auxiliary files that we will need along the way, and for you to maybe redo some or reproduce some of the things that I'm doing here. But for now, this is not really necessary. We are not really building anything productive. We are just messing about and learning, which is like the first 3 lessons of this course, and then we start into the actual dApp development, which is going to be fun. But for today, I just want to get into ethers. The next session will be on Thursday, so in 2 days at 8 p.m. European time zone again. I'm sorry if that's not really a great time for our friends in the Americas. I'll try to do something to accommodate them as well at some point. I don't know yet how, but there will be maybe some late night sessions or something like that to do that, or very, very early morning. Let's see. Cool. So what is ethers.js? I opened up the documentation here. As I said earlier, ethers.js is a library that helps us abstracting away most of the tedious work that you have to do when interacting with smart contracts. I highly recommend you to check out the last episode. You can watch it at 2 times speed or 1.5 times speed or whatever. It's not super important that you get all this, but it just shows how tedious it is to actually make transactions or make calls to smart contracts. And ethers.js makes that a lot easier. As I mentioned earlier, there's an alternative which is quite popular, which is Web3.js. It's actually, as far as I'm concerned, it's older. So it has a longer history. I think it was kind of the first JavaScript library that allowed you to access smart contracts from the browser or Node.js. And it's came a long way. The thing I think there's a long debate on what to use, really. I don't necessarily want to go into that here because this is about ethers. We have to kind of pick something. And within Colony, we kind of settled on the notion that we want to use ethers for some reasons. One of them being, for myself, I feel like it's more concise and it's less guesswork what you have to do. And it's producing quite consistent results. As I said, I don't want to really go into the details here, but I prefer it, maybe because of the API, maybe because of I'm just used to it. I just haven't worked with Web3.js for a long time, and I cannot really tell whether it's better or not at this point. But all of the concepts that I'd be explaining here, you can map them not really one-to-one, but you can map them like from a concept side of things, you can map them to Web3.js as well. Cool. With that being said, let's dive into ethers. We want to touch on a few concepts really before we get going. So today I'm just going to be explaining a lot of concepts of ethers.js, and then we apply all of these concepts to talk to a smart contract. Again, just like last time, it's going to be a different contract, I think, I hope. But yeah, we just want to explain the concepts, and then we just want to apply them, and we want to see what's actually going on. Because this is always a better way to learn, in my opinion, to have like to do something and have an example of all of this. So the first thing I want to mention today is providers, really. Because there are so many ways to talk to Ethereum, and for example, the RPC protocol that we touched on yesterday is by far the most popular, but it's not the only one. That means ethers wanted to have a way, or usually these libraries, they have a way of abstracting that away from us, or they're basically saying, okay, I don't really care how I'm going to communicate to that node. I just care that it has all the functionality that I need. That means in the end, providers are a way of telling ethers in what kind of way you want to communicate to the node, to the Ethereum node. And a very popular way, so it's kind of annoying, ethers removed their search functionality from version 5 to version 6. So I'm going to use version 5 for now. Nothing much changed in terms of what we are looking at. But I just want to show you some things. So let's check out the docs for the JSON RPC provider. Okay, as I said, RPC to JSON, this protocol is by far the most popular one, and Ethers has a provider to abstract this protocol away from you. Basically, you can say, I have a node that I want to talk to. If you remember last time, we talked to our colony node via this protocol, and then you have to basically tell the provider the address and the port and any other kind of connections that you might want with this node. And then you can basically just forget about the provider, because all of the internal implementation of that provider you don't need to worry about. You can just give it the address and plug it in, and then basically forget about the fact that you have a provider installed. And that's kind of the amazing thing, because like what we did last time is just we only talked with this kind of RPC node directly. And we only had this kind of communication protocol. But here we basically just say, there's a provider. We don't care how it's working internally, but it just works. So yeah, this is pretty great. So the JSON RPC provider is basically the way to do it, and the way how we would instantiate it is, let me just write it down here somewhere. Oh, maybe I can just use a file that we create. So let's just call it example.ts. So it's a TS file. Doesn't really matter. No, actually, let's make it a JS file. I don't have TypeScript installed here. Let's just make it a JS file. Doesn't really matter. The way you would do it is you do get the providers from ethers. Oh, I didn't tell you about the most important thing, how to install it. So you have a Node project, and then you do npm install ethers. And that's already it. Just save it to the node. I don't even know if it's necessary. And now we have it installed. And the way it would work is you'd say, okay, I have a provider and you want to instantiate it. And then you say providers, I think JSON RPC. You have to say new JSON RPC provider. And the argument here will be the URL to your RPC node. So for colony, that is, I think I forgot that again. Let me just quickly pull that up. I still don't know it by heart, even though I should by now. Just want to not run into issues. So there we go. xdi colony.o RPC. This is the Gnosis chain provider, the Gnosis chain endpoint for our own node. So this is how you instantiate a provider, and then basically you don't have to worry about it anymore. This is all you have to do. Cool. What do we have next? If you have any questions regarding providers or anything, let me know. I think it's a kind of a fairly straightforward concept, especially if you because you don't have to worry about the internal implementation of it. I think I wrote a provider once. I don't really remember what I did with it. I think it was in some sort of adapter. Yeah, it is quite tedious to write it yourself, because then you have to kind of implement all of the JSON protocol that we just saw. But that we saw last week. But for here, this is all we need to do. Literally, just instantiate the provider and we're good. Okay, let's talk about signers. Signers are like for Ether, in Ether's terms, signers are the broad concept of something that can sign a transaction and a message. I don't know, you might have seen, like when you work with dApps in your browser, and you might have seen just some messages popping up. Basically, hey, can you please sign this message? Most of the time they're using this for some internal or server authentication. And this is basically the sign message functionality that a signer provides, and it can also sign transactions. And this is basically everything signers do. So they're kept deliberately very general, because they can be a lot of things. You might know MetaMask is definitely not the only signer that is out there. So MetaMask, for example, is a signer. You can just use your private key directly to sign things. It's not recommended, but it's possible. You can use a hardware wallet. A hardware wallet is a signer, or let's say a hardware wallet can be a signer if you're using the right library for it. And also like online wallets or any kind of wallet provider that you might know can be signers in an Ethers sense. If you want to talk to MetaMask, there's a special way of kind of getting the signer from MetaMask, but we're going into that the next time, actually on Thursday, on how we connect our Ethers library to MetaMask. So that are signers. And I want to go into a specific signer, which is a wallet. So a wallet implements everything that a signer needs. And a wallet here in our case is just an Ethers wallet. And this is a whole wallet implementation, which is pretty cool. That means you could, for example, for testing or things like that, or if you want to do contract deployments or all kinds of other purposes, you can actually use a private key to just give it to Ethers. It's not recommended to use it for your day-to-day transactions, but if you want to do some development or if you want to do some testing or deployment, it's definitely a good way or an easy way to do certain things. Or, for example, if you want to have something that runs on the server. The example that we are putting together today is a Node.js example, so it might as well run on the server. So then you can use a wallet to just generate or create a wallet instance, which is a signer based off of a private key, which is pretty cool. Furthermore, what do I want to say? I don't remember. Furthermore, you can, for example, create a wallet from a mnemonic phrase or something like that. Or I think Ethers even supports the old JSON wallet protocol, or the JSON wallet specification, which is definitely also not recommended because it just holds a whole wallet in a JSON file that you keep somewhere. I guess it's fine, but in the end, a private key would also be even more secure, or just use something else, like something more secure like MetaMask or even a hardware wallet. That would be nice. Okay, so with that out of the way, we know now what a wallet is in Ethers. Now I want to get into the concept of a contract. I had it open before. Let's try to find it in the V6 documentation. So if we say contracts, and I think yes, as you can see, the Ethers documentation is lacking, and I'm sure they'll be happy for any kind of contributions to the documentation. This is just auto-generated. I think maybe it wasn't getting started, and here contracts. Oh yeah, exactly. So you can see an example of that. If you remember last time, we generated, or we basically used an API that was generated when the contract was compiled. So Ethers can just read that as a JSON format, for example, and create a contract abstraction out of it, which is pretty cool because then this contract abstraction will support all of the functionality of this contract, and you can just use it as a JavaScript class. So you don't have to worry about like what functions do I have, or how do I actually call them, or how to prepare all the data for it. You can just call a contract function as if it was a JavaScript function. Essentially, you're calling a JavaScript function, which is then translated behind the scenes into the right protocol that your provider takes. So you can see here that we can see there's the API, of this. This is the token contract, and then we just instantiate a contract like this. So a contract, and you say new contract, and here we have the contract address, and we take the API and the provider. One cool thing that I forgot to say about the providers is they also have a way to kind of auto detecting the chain you're on, so you don't really have to worry about that either. If you're connecting to an RPC node, and then ethers will basically just ask, hey, what chain are you operating on? And then it will just return the correct chain ID, and then you don't have to worry about that either. So you just connect to the right node, you know what kind of chain this node is on, and then it will just work, hopefully. Right. So I want to do an example now. Let me know if you have any questions regarding any of this. I wanted to dive into a concrete example on how we would use ethers to, in this case, mint an NFT. I deployed an ERC-721 NFT contract on to Gnosis chain before. You can see it here. This is the output that I had. This is my wallet, my demo wallet address, and this is actually this one here is actually the contract address. Oh, sorry. No, it's happening here. Well, this is the contract address of the deployed NFT contract. And this is just a transaction hash. I just put it here for debugging purposes in case we need it. So now we actually have all of the information that we need, except for one thing, and that's the API. And I already prepared that as well. I know I said no shortcuts, but usually this is what you get from your favorite smart contract developer. You don't usually generate the API yourself. And if you have to, it's kind of a tedious job. I mean, I guess we can make a video about that as well, but this is not really part of this course. So we just assume that you have the API from somewhere. In this case, I have the contract here, which is an NFT contract, which supports metadata, which is like the default contract that you would use for things like OpenSea or something. And for that, I generated this API. It's a really long kind of file, which contains all of the ins and outs of the contract functions, and all of the types and everything. But also even more, it doesn't only contain the API, but also contains the whole bytecode. And the bytecode, for example, is the binary code that you would need to deploy it. This was actually what's actually being written onto the chain when you deploy it. And there's a source map and all kinds of other auxiliary information that we don't really need. Most important thing is that we have the API, and we can see here it's under the .api field in this file. Okay, yeah, let's work on our example. Let's see. Maybe I should make it TypeScript. That's fine. I guess we'll be fine. There might be some more issues when compiling, but it's just the way it is. Okay, so we have the provider from before. Now we need an async function because most of the stuff in Ethers is asynchronous. So let's call it, let's call it start. I usually call it start. And we say, actually, yeah, we can also make the signer. And as I told you earlier, a wallet, for example, is a signer. So we can say new wallet. And then I have actually exported a private key here, which is in process.environment private key, so that we can actually make a transaction and not only look at things. So the way, let's just call this wallet. So now we have a provider and a wallet. The way we connect these two things, because we want the wallet also to use the provider and the provider to use the wallet. Sometimes you will need that. For example, when you make a transaction, Ethers will ask the provider, hey, give me your signer. And the signer says, I don't have one. And then transactions will fail. So with that being said, you can instantiate contracts with just a provider and no signer. But that means you cannot actually make transactions. So that's one thing to keep in mind here. Cool. That means the way we would connect these are, I think it is, if we say signer and then wallet, actually have, I think I might have made a mistake with the provider import, because I'm still used to Ethers v5. We'll take a look at that later. No shortcuts. Wallet connect, and then we put in the provider. We have provider any. I think that's probably not correct here. Oh, look at that. They are exported directly. So if we do JSON RPC provider, and that should be fine. Now it's a JSON RPC provider. Oh, nice. Okay. And this is also something that we have to wait as far as I'm concerned. Oh, actually not. No, we don't. Okay. So, and this returns our new signer, which is connected to the provider. Most of the time in Ethers, whenever there's a provider, you can also put in the signer, and when there's a signer, you can also put in the provider, and then Ethers will kind of figure it out and just take what it needs. If you have connected them like this, it will just work, and you can do whatever. But I would recommend to do it like this, to actually always put in the signer, because it's just easy, and you know, the signer is definitely a signer, and it can also do transactions. Next thing we need is to actually require the ABI. Let's do that here, and there is the fish plethora.json and then ABI. Actually, we can do it like this: ABI. And yeah, here we can see, there's a whole bunch of stuff going on. This is the ABI that Ethers will need to connect to our contract. Cool. Now it looks like we have everything we need to connect to the contract on chain. So let's do that. and we just call it fish NFT. And we need to get contract from ethers. I hope that's correct. Yes, it looks like it. And then we can say new contract, and let's get out our contract address here. Oops. And then we have a contract. Two more things. API. Let's stick to the and the signer. Stick to the docs here. Cool. So we gave ethers the API so that it knows what kind of contract to build here, and we gave it a signer to know like what wallet we need to use and what provider it should use to connect to the Ethereum node. Cool. I would like to just run this now and see whether we made any mistakes or anything like that. So yeah, let's just do that. Node example.js. Well, there's no error, but there's also, oh yeah, I know why. We were expecting that there was a console log, but we actually have to call the start function here. And let's see what happens. Okay, so, and we can see there's a whole bunch of stuff going on. There's our target, the contract, there's a bunch of other internal things, and we can also see that there's our wallet with the provider that we gave it, and also the wallet address, which is cool. So that means it works. It got the private key, it generated the wallet out of it, it got the wallet address from it, and we seem to be set up for success here. So let's move on. So we have the fish NFT. So I guess as far as we are concerned, it didn't really talk to the node yet because we didn't ask it anything. We just set up the contract with local information. So we basically just now try to ask the contract something. And for that, I have pulled up the ERC 721 specification, and there we have a bunch of methods. Let me see, let's take actually a look at the one that I deployed. Tokens, and I think this is the one I deployed. So we could basically ask for its name or its symbol, because I think I gave it that. So let's do that. And as you can see, TypeScript won't suggest the name of the function here that we want to do, that we want to call, because it doesn't have any notion of the internal structure of the contract, because TypeScript doesn't read the API, only Ethers does. What you can do though is use something like typechain, which will create TypeScript typings for your APIs, which is super cool. And then you have typed contracts which you can use very confidently, and you know, this is the function that I call, and you know all of the parameters, and you know all of the types of the parameters and everything. So that's pretty cool, and I highly recommend using that if you're using TypeScript. But for now, we don't have it, so we just say name, and we know this is an asynchronous function, so we have to await it. And I guess hope for the best. Let's see what it comes up with here. I actually have no clue what the answer will look like here. Okay, so we actually asked it a question. We asked our contract, what is your name? And it replied with a plethora of fish. So we know our contract is deployed. That's cool. And we know that we did everything right so far. So let's move on. Let's go back to our example and actually try to do a transaction. That could be fun. So let's deploy an NFT. With that I mean mint. So let's look at the one function that I added here. This is a mint function. Which basically just deploys or mints the fish token, and it wraps these two other functions that are internal implementations of the contracts that we pulled in here, which are the reference implementations of the NFT token. If you write your contract address, if you want to have a fish, and you should write your wallet address into the chat, I'll deploy it to your wallet address. I mint it to your wallet address. It's on Gnosis chain though. And if you don't want it, I've mint it for myself. I know my address. Keep in mind that it's going to be a public address. So maybe create a new one. So then I prepare some further steps. Await fish NFT dot mint. Okay, now we have to go back and see what it is. Address, token ID, and URI. Token ID is going to be 1 because I haven't minted any token yet. And the token URI I have in my notes. I'm not going to go into details how NFTs work here. This is not part of the course. But I prepared a little NFT on IPFS and have 2 hashes, and we are using the metadata hash here to use for deployment. To use for minting. Why am I always saying deployment? So there we go. And as no one posted their address, I'm just going to use mine. If I can find it. So this is a demo address, so don't bother looking that up. Okay. Now let's see. As you've seen, contract calls are extremely easy with ethers. We just basically said fish NFT name and we awaited it, and then it immediately replied with the correct function with the correct formatting. We didn't have to decode anything. It just worked, which is super cool. And now we can actually go into a little bit of a more complex territory, which is extremely hard to do manually. But in ethers is also easier, but not as straightforward as sending a function call. So what we're doing here is calling a transaction, a mint transaction, which will, by the way, fail if you don't have a signer. So Ether is just going to try to sign this transaction. And it will fail if there's no signer connected to your provider or if you don't have a signer put in at all. Cool. Then from calling or from executing this function on the contract, we will get a transaction object back. And if I'm right in my assumption, then let me see, transaction. Again, I'm not really comfortable with the Ethers v6 API yet, so let's just go through it together. Methods, clone. I'm not finding what I'm looking for. I think it might just be something else. I think it might not be a transaction that we're getting back. I think it might just be a transaction response or something like that. Yeah, as I said, the API, transaction response, the API is not the greatest. Oh, there we go. Okay, it's still the same. So they didn't change much. So what comes back from any transaction when you call a call function, so to say, on a contract, ethers will just give you back what the contract has answered. It just immediately, just plain. When you execute a transaction, it's different. Then you will get, the first thing you will get back as a transaction response. And that could be whether, and that's going to be sent in any case. But even if the but you get that back immediately with like a transaction hash. So you will know the transaction hash. But that means the node has propagated your transaction, but it doesn't mean it's been mined already. So there's another function on the transaction response, which is wait. And that actually waits for your transaction to be mined. And you can even specify how many confirms you want to be extra sure that the transaction has been mined and has been taken care of. And then you have the result of this transaction. So the first thing you get is a response. If you get a response, that's good, but it might still fail. It might never be mined. This is just the nature of the Ethereum blockchain. So in this case, we have a wait function that waits until it can find out that this transaction was mined. And this is what we are going to do here, because then we know that actually happened, and we can see certain things that happen on the blockchain, as opposed to just getting the transaction hash. Nothing has happened yet. We don't know. And if it's actually mined, we can tell, oh yeah, there's some stuff happened, and then we can inspect it and we maybe see some interesting things. So let's call this response for us to have a better name here. And then let's wait. Response.wait. So wait actually returns a transaction receipt, as you can see here in the docs. And the transaction receipt contains a whole lot of information about the transaction, including all of the events that have been triggered and all of the if you need more information about like in which block it was included, and all kinds of other stuff that we are going to take a look at. So we are not logging the response on purpose. We just log the receipt here. Let's remove this. Actually, let's leave it. It's fine. Okay. And then hopefully we will see that an NFT was minted. Let's see. This will probably take some time if it works. Up to 15 seconds on Gnosis chain. Oh, there we go. Cool. So we can see this is our transaction receipt. It looks like it actually worked. So we have the provider again. This is the contract that we made the transaction to. This is the contract, this is the address that made the transaction or sent the transaction. This is the transaction hash. And we see the block number and all kinds of other stuff. So that's pretty cool. Now let us check the hash against Block Scout maybe. See what happened. Okay, so we can see our transaction that we just sent is actually confirmed, and it interacted with our contract, a plethora of fish, and it's called fish token, as you can see. And you can actually see that token was minted. And yeah, there we go. Token transfers. So I have a fish token now, fish NFT. I wish I could show you the fish token, but I cannot because OpenSea doesn't support Gnosis chain. I guess you just have to take my word for it. Or maybe you can know like a NFT explorer that supports Gnosis chain. I don't. But yeah, this is the result of our transaction. So that's pretty cool. Yeah, fish token. Yeah. I would say this is all I wanted to cover for today. I wanted to keep it a bit shorter because all of this highly theoretical stuff might be boring after some time. So an hour was kind of my time cap today. We did all of the agenda, all of what I came here to do. We minted a fish token using ethers.js, which didn't really take a lot of code, as you can see. So we just have the new contract. If we remove these two lines, then it's just like 15 lines of code or 17 lines of code. And that's pretty cool. And this is with all of the setup, everything. So if we would have done it in, or if we did it in a completely different or completely manually, then this would look pretty crazy. But in Ethers, you can see this is pretty straightforward. This is actually readable. So yeah, I'm looking forward to where we're going with this, and yeah, quite excited to use more of this to build our cool project. Next time we are going to look into how to connect ethers with MetaMask. And we are going to create a little front-end application as opposed to this Node.js application is a bit boring and you always have to have a private key ready. I think what's more exciting is to see how we can actually connect ethers and our smart contracts with MetaMask and just have a website that people can interact with and basically build our first tiny dApp. So this is going to be next time. Yeah, let me know if you have any more questions for today, for ethers or anything. Just ask away. If not, I will leave it at this. And I can just say, I hope I see you next time. And if you just watched this on YouTube, I hope you enjoyed the video. Let me know in the comments if I need to cover, or if you want to have anything else covered, or what you're generally interested in, and maybe we can make that happen. All right, I'll see you next time. Bye bye.